Um, so in today's classwork, you're going to be doing a little bit from 7.1 on there if you're kind of trying to figure out what the EOO mean. That means every other odd. So you're going to go back to 7.1 and do every other odd on the negative and zero powers. And then I'm going to introduce you to the third of 5 rules. And the third rule we're going to discover here. Here's how it works. You may know, I don't say anything yet, but if you go back to the definition of what it means to be 3 to the 4th, that's 3 times 3 times 3 times 3. And the definition of 3 squared would be 3 times 3. If I count up all the 3's, I have 3 to the 6 because there are 6 3's represented there. So it works for a base 3. Does the same thing work if it's an x? Well, x squared means I have 2 x's I'm multiplying. X to the 7th would mean 7 x's. If you count up all the x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, I have x to the 9th. And then the third one, I've thrown a third exponential expression at you. Remember that the unwritten power on that 2 is 1. And so I have 2 to the third is 3 of them here, and then another 3, and then a 2 to the first. And if you count them all up, we have 1, 2, 3, 4, 5, 6, 7. And so what we discover here, what are you seeing? What's happening here? How could I avoid writing out all the 2's? See a pattern? How can I know how many 2's or how many x's or how many 3's I have here? Yeah, just add up the exponents. And that's the third rule. Anytime you're multiplying same bases, you add the exponents. So let's do that with these 12s. Here we have 12 to the 4th times 12 to the 3rd. It's the same as 12 to the 4 plus 3. If I were to show my work, I'm just showing that I'm adding the powers. Or 12 to the 7. And even with a negative base, it's just copy down the negative 5, add the 2 plus 7. So negative 5 to the 5th. And then there will be times where they'll ask you to, on the calculator, go ahead and type in negative 5 to the 5th and find the number. Okay. Why don't you try the 3 down here? Just take like a minute to rewrite these just as a base to a power. You don't need to go to the calculator and evaluate it. Just base to a power, and then I'll do them and we'll check. Okay. So looks like you got it. This would be 8 to the 9th. Did you get that? What'd you get on this one? Yeah, so you got to deal with that negative power. And then this one is 0.5 to the negative 11. So that's the new rule. When you're multiplying the bases that are the same, you just copy down the base once and then add the powers. Okay? Now here we're going to kind of mix things up a little bit. We have some numbers out in front of the z's here. And what a lot of students will do is they get into the mode of just adding everything. We don't add the 4 and the 9. As a matter of fact, the 4 and the 9 we're going to multiply. And then you will add the powers on the z. So it's 5 plus negative 12. And so I end up with 4 times 9 is 36. and then z to the negative 7th. So I add the powers on the z. I multiply the numbers together. Okay? Remember not to add the numbers that are out in front. And then I have one more step to do here. This goes back to last lesson. I have a negative power attached to that z, right? So what do I need to do to make it positive? I have to move it. So this is 36 over z to the positive 7th. And only the z moves. The 36 stays on the top. Because what's the power on the 36? To 1. Yeah, and that's positive, so it stays. What about this one? If you multiply all the numbers together, do you see the 2 and the 9 and the 3? All right, we got to multiply all three of those together. So 2 times 9 is 18, times 3 is 54. And then I add the powers on the a's. We have an unwritten 1 on this first a, and we're going to add that to the 2 on the second a. So I have 1 plus 2. And then the b to the 4th, I do not add the 4th power on the b to the powers on the a, because you only add powers when the bases are exactly the same. So my final answer here will be 54, a to the 3rd, b to the 4th. So that's kind of a combination of when you have more than one letter in the problem, only add the powers on the same bases or same letters. If you have numbers out in front of these letters, you're going to multiply those numbers together. And then don't forget the little unwritten 1 that you have on something like that first Now You Try. So go ahead and do the Now You Try problems, those 3. See if you can completely simplify those. Remember that no negative powers. All right, so the first one here is 15x to the 4 plus 9 plus 1 is 14. This one we just have the 12 out in front, j to the 3rd, and then the k to the negative 2 will move to the bottom and become k to the positive 2nd power. And the last one on here, we do have a negative sitting out in front of the 4, so it'll be negative 4 times 7 is negative 28, times 2 is negative 56. We've got c to the 1st, which we won't write the little 1 on there. You usually won't see the 1 power written. It'll just be c, and then d to the 2nd. Okay, any questions on that? In what is scientific notation? We use scientific notation when we're talking about really big things. So if you're talking about planetary motion and planetary distances, speeds or distances, it's with big numbers, right? We use scientific notation for that. We also use scientific notation for really small things like microbiology, things like that. So with really big things, you're going to have a number times 10 to a really big positive power. And if it's really small things, it'll be a number times 10 to a really negative power. And the way this relates to what we're doing right now is that the 3 and the 2 are like the numbers out in front. Okay, there'd be like the numbers out in front of it, like the examples we just did. You'd multiply those together. And then the 10 is like the variables. The bases are the same, so you would add the powers. And so we end up with 6 times 10 to the 12th. When we multiply these two numbers together in scientific notation, we can then give an answer in scientific notation. Now, to be in scientific notation, each of these happens to be in scientific notation. We call this number right here the R. And the R must always be between 1, including 1, and 10, not including 10. In other words, you could have 1 times 10 to the first, or you could have 9.99999 times 10 to the first, but you can't have 10 times 10 to the first. I mean, you can write it that way, but that wouldn't be an official scientific notation form. So scientific notation, both of these numbers are in scientific notation. But I say this because what happens if we multiply two numbers in scientific notation like these two? We do the 4 times 6 and we get 24 times 10 to the 8th. Now that's fine. You might even, you might see it written like that. It's not a problem. Except that if you're asked to put it in scientific notation, 24 is not between 1 and 10. Have you guys heard this before? Talked about scientific notation? No, some yet. Well, you haven't. You will eventually. Eventually, as you get into biology and chemistry, I think you will. And if you take physics as well. But 24 times 10 to the 8th, here's how we change it. Would you agree that 24 could be rewritten, if I move the decimal one place over to right here, 2.4 times 10 to the first? I'm just going to put that in parentheses because I still have the 10 to the 8th hanging out here. But think about this with me for a moment. If I take 10 to the first, that's like multiplying 2.4 by 10, right? If I multiply 2.4 by 10, do I get the number 24? Yeah. If I multiply 2.4 by 10, I get back to where I started. But 2.4, is it between 1 and 10? It is. 24 was not. So 2.4 times 10 to the first times 10 to the 8th. My final answer then would be 2.4 times 10 to the 9th, and I have it officially in scientific notation. Why don't you take, you're going to do the same thing I just did here with this problem right here. Go ahead and try that. And this can be done with any number by moving the decimal over. You can force that number to be between 1 and 10. And then change, do a times 10 to whatever power, and then you'll rewrite it. I might add one more example in here too, just so you're ready for the classwork. So this would be 18 times 10 to the 14th. 18 is not between 1 and 2. And so I'm going to rewrite it as 1.8 times 10 to the first. Then I have times 10 to the 14th hanging out here. And so my final answer would be 1.8 times 10 to the 15th power. Now, when you get problems like this, they won't necessarily be written in scientific notation already. You might have something like this: 0.6 times 10 to the 9th times 0.3 times 10 to the 5th. Well, 0.6 times 0.3 would be 0.18, right? 0.18. We'd multiply the 3 and the 6, which is 18, and then move the decimal 2 places to the left. So this would be 0.18 times 10 to the 14th. How could I rewrite 0.18 as a number between 1 and 10? Well, here I would move the decimal 1 place to the right. So I would have 1.8 times 10 to the, what power does the 10 have to be in order to move it back one place to the left to be 0.18 as opposed to 1.8? You know what power it would have to be on the 10 to move it left? What's that? Okay. Yes. In the end, yes, you're right. You're thinking ahead. That would be a -1. I have the 10 to the 14th hanging out here. Some of you may be able to do this in your head. That's fine. I just want to show what's happening here. So 0.18 is the same as 1.8 times 10 to the -1. The 10 to the -1 would move the decimal one place to the left because, as we learned last time, 10 to the -1 would be equivalent to dividing 1.8 by 10. And when you divide a number like 1.8 by 10, it moves the decimal one place left, as opposed to what we did up here. When we multiplied 1.8 by 10, it moved it one decimal place to the right. So that's just something you have to think about in your mind. That's straightened out. So this would be 1.8 times 10 to the 13th in this case. That's all. Good. Any questions on that? There are just a few problems towards the end. We're going to be doing more with scientific notation just because it's something you need to have a grasp on as you move into, especially biology and chemistry and physics. Those three lab courses, you will run into this. So we'll revisit a little bit of this at the end of each lesson in the next couple lessons, okay? But really simple today. It does relate to our new rule because the tens act like your variables. They're the same basis, so you add the powers. So write a little summary here. You might want to just, in your summary, just write, you know, if I'm multiplying two things that are the same basis, what do I do with the power? Write down what you do with the power example.